Welcome. In this video, I'm going to try to explain a pairwise binomial test that can be used after a Pearson chi-square test of goodness of fit. We're using this test when we're analyzing a nominal variable, or sometimes, and so far we've already seen how to get an impression from a nominal variable using a frequency table. We've seen how to visualize that table using, in this case, a bar chart. And we also already done a test, the Pearson chi-square test of goodness of fit, that showed that there are some differences between the categories, or actually that not every category was chosen equally often. In this video, I'm then going to talk about how you can determine which categories will be significantly different from each other. Because this is a test that you perform after you've already done another test, it's sometimes referred to as a post-hoc test. The definition of a post-hoc test is a statistical procedure conducted on the basis of the findings obtained from previous analysis, according at least to the APA dictionary for statistics. And that's exactly what we want to do here. We've already determined that there is an impact from that not every option was chosen equally likely, and we now want to do another test based on our previous findings. What we're going to do is we're going to have a look at every possible pair of categories. So for example, we had married and widowed, so we can compare those two. Are those two significantly different from each other? Or married and divorced, married and separated, etc. So as you can see, quite a lot of different tests that can be performed. So that's why it's sometimes referred to as a pairwise test, because we're just picking two every time, so that's a pair. Now, if we have only two options, then actually it's no longer a nominal variable. Well, it still is, but we can now specify it even further to a binary variable. And from a binary variable, I've already made another video on how you can actually analyze those. So what we can actually do is just use the statistical test for that, which is a binomial test. Now, you could also actually perform another Pearson goodness of fit test, or sometimes even also a z-test, but I'm going with the binomial test. So I'm not going to explain the whole binomial test again, because I have a separate video on that. So watch that one if you're interested. In essence, what it does is if you have two categories, it checks if both of those options were chosen at 50%, or the assumption is that they were chosen at 50%, and then the test will show if it's significantly different from that or not. If you have all those possible pairs, then these were the significances. As you might notice, in this case, almost all of them are very close to zero. Only divorced versus never married is on the board with really a number, 0.003. The other ones are, we would report this usually as less than 0.001 because they're very close to zero. There is a small catch, however, because each time when we do a test and we set our threshold at that 5%, at 0.05, then we have a 5% chance of making a type 1 error, rejecting the assumption even though it's actually true. Now, this is fine if we just do one test, but every time we do a test like this, we have a chance like this. And that means that there is quite a large chance, if we do multiple times this test, that at least once we're making the wrong decision. So to adjust for this, there are a whole lot of different kind of corrections you can use. One of them is from Carlo Emilio Bonferroni. I'm not sure if I'm pronouncing that correct, but that's one that you will often see. It's a little bit conservative, but it's also fairly straightforward, because what he actually came up with was to simply multiply the significance that you find with the number of tests that you are actually performing, of course, to a maximum of 1. So this is a very simple correction, but at least you're then taking that into consideration, and usually it's recommended to use one of these corrections. There are a lot of other ones, and perhaps some of them could be better suited in your situation, but Bonferroni is one that's often recognized and quite frequently actually used. So as you can see in my data, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different comparisons. So I multiply the 0.003 times 10, and there it becomes 0.026. Now that's because this was actually rounded, so this was probably 0.0026, and now it's 0.026. That still means it's significant. It's still below the 0.05, and all the other ones even still remained below 0. So in my situation, all of the categories were significantly different from each other. Now, most likely you won't be calculating all of this by hand, so don't worry. I have various instruction videos on how you can obtain this adjusted significance. If you go to my website, which is peterstatistics.com, then you can actually go for one variable. Then you can choose a nominal variable. That gives you the menu here on the left-hand side. If you then go for post-hoc, you should be able to see something like click here to see how to do this with, and then you can click on either SPSS, R, Excel or Python, and it will show you a video on how you can determine these adjusted significance of this post-hoc pairwise binomial test. Ooh, that's a lot to pronounce. I must admit, SPSS, the video will also make use of Excel because SPSS unfortunately doesn't have an easy way to actually obtain all of them in one go. But if you have a little bit of Excel skills and SPSS, it should still be doable by watching that video. In our report, we already had the result of the generic or the omnibus chi-square test of goodness of fit. And now we can add to this that the binomial test, the pairwise comparison with Bonferroni correction of the marital status showed that all proportions were significantly different from each other. I then reported the highest one, which was the p-value, the significance of 0.003, or actually it was slightly less than that. So that's the one I report. It always depends a little bit on your outcome, how you can perhaps easily summarize the results. Sometimes you can just give a small table with all possible comparisons and then which highlight the ones that were or were not significant. But that really depends on the outcome of your test. But in this case, each category had a significantly different proportion than all the other ones. And that's what a post-hoc pairwise binomial test can actually do for you. It's used after you've already done an omnibus test. Then you can, and you want to see if the proportions between two categories are significantly different. And that's why it's a binomial test. Or like I mentioned earlier, you could do another goodness of fit test or a Z test, but I think the binomial test is fine. Hope this made it a little bit clear what a pairwise binomial post-hoc analysis is. If you're interested, have a look at the videos on how to get those results with either R, Python, Excel, or SPSS. Thank you for watching.